Okay, so here's 9.2, number 2. In my original video for 9.2, I'll do it. You'll see me, I go through 9.1, and then I must have paused it thinking I was teaching and didn't record myself, and then jumped straight to the DIY for number 3. So I'm going to put in number 2 here. Again, we're working with that standard form of an ellipse. And so one of the things we want to do is with the ellipse, kind of like the circle, we want to keep the x's first. So I'm going to keep 49x squared here. And then there's a minus 98x. And we'll be adding a new number there, but we got to be careful. And then there's a 16y squared minus 32y. We'd add some new number there. And then the 719 has to go over here as a positive 719. So the first thing we should always do is factor out so that I have this imaginary 1, right? Or not imaginary, really. It's still a 1. We just don't have to write it. And but then you have to factor the 49 away from the 98, so that's negative 2x. So that's how we start it. And then I will factor the 16 away from the y squared, which will also leave me with a minus 2y. All right. And then the idea is now we have this new middle term, negative 2. So I'm going to take negative 2, divide by 2, I get negative 1. I square it, which is positive 1. So I'm going to put a 1 here. And too often, students put plus 1 over by the 719. You're so used to adding 1 on both sides. But what we want to do is, I talk about drawing like a dotted line to the beginning. I factored out a 49. 49 is multiplying everything in here. So I have, by putting the 1 over here, I've really changed the problem by 49. So I need to add 49. Then I take the negative 2 for the y value, this new negative 2, divide by 2, I also get negative 1. Squared is 1. So when I put a 1 here, and I do the same thing, I draw this dotted line to that factored out number, so that's 16. Even though I put a 1 in the problem, I've changed this problem by 16, so I'm going to add another 16 over there. And now we just need to go ahead and clean this up a little bit. And so I have 49x minus 1 quantity squared plus 16y minus 1 quantity squared. And remember, we know that because there's a 1, or excuse me, the negative 1 in the parentheses right there. So those just drop in. Those do. And then over here, this all adds up to 719 plus, that's going to be 784. Now remember, with the ellipse, we want it equal to 1. So the very last thing we're going to do here is divide everything by 784. And the idea is, when we do this, we have this 49 over 784. So if you go to a calculator, and this thing's resetting on us, so if I do 49 divided by 784, and I get that, then I'm going to hit math, enter, enter, and I get 1 over 16. So if I come back over here and I write 1 over 16 times x minus 1 quantity squared, I really don't need the 1 on top. So basically, when you look at this fraction out here, I'm just going to have x minus 1 quantity squared over 16. Then you can take the 16, you probably already know what that is, 16 divided by 784, since 49 over 784 is 1 over 16, 16 over 784 should be 1 over 49. And there it is, 1 over 49. So I can just go in here now and type y minus 1 quantity squared over 49. So there is my standard form. So what I can do with this is I can go to the graph, and I know my center is at 1, 1. And then with the ellipse, we should always do the bigger denominator first. So I'm going to take this 49. I'm going to take the square root of 49, and I get 7. But because it's under the y, I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7. These would be considered my vertices because they're the biggest denominator, the major axis. I went up and down 7 because it was under the y. So if my center, right, was at 1, 1, I guess I could make this a little bigger. Then if I went up 7, this vertex would be at 1, 8. And this vertex would be at 1, negative 6. So if you go up and down, your x value doesn't change, your y value does. And then under the x is a 16. So if I do the square root of 16, I get a 4. So I'm going to go sideways, 1, 2, 3, 4, and 1, 2, 3, 4. So if I go to the right and left, these would be called co-vertices, and you're going to add the 4 to that x value. So that's going to be 5, 1, and subtract it this time would be negative 3, 1. And now you can draw in the ellipse. And what you can see is it's a little bit more vertical, like it's been stretched vertically and not necessarily horizontally. And then the last thing would be to find the focus or foci. So I'll just put it in here. So that formula for it is c squared equals a squared minus b squared. You can't really mess that up. If you add them, it would mean your focus points end up outside the ellipse. And if you subtract small minus big, you're going to get negative 33, and you can't square root negative 33. So my c would be the square root of 49 minus 33. A squared is 49, the bigger denominator. B squared is the smaller, technically. And what you're looking at is c is the square root of 16. Oh. Should have been 49 minus 16. I was already thinking ahead of the problem, which is the square root of 33. So we know that's 5 point, something. So if you want to get a little better estimate, what's the square root of 33? About 5.7. So if you go in the direction that it's stretched more, the major axis is up and down. So we're going to go up and down 5.7. So I just go up 1, 2, 3, 4, 5, and a little bit more. Here's one focus, and go down 1, 2, 3, 4, 5, and a little bit more. Somewhere in here is the other focus. Now, that one would be considered 1, because I didn't go left or right. But I just write it as 1 plus the square root of 33. And then this one, I would just write as 1 comma 1 minus the square root of 33. And there would be your completing the square and the graph for 9.2.